Thank you all for joining me for today for a 101 in time series data. So I've said to you, a few of you already, this was actually meant to be my debut talk at InfluxData. But COVID permitted. We are now almost a year on. I'm almost a year older and uglier. So we're now giving this talk, and hopefully it's a little bit more interesting to you than what it would have been when I first started as my debut talk. So if you didn't know, I am Clifford. I'm a developer advocate for InfluxData. So I used to actually be a sales engineer for industrial IoT solutions. I have a passion for autonomous and robotic-based projects, and I like to make IoT accessible to all. In my spare time, I enjoy a bit of swimming, yoga, and wakeboarding, and I am also a bit of a gamer, so I'm currently playing Total War Warhammer 3. It's a fantastic game, rocking the Celestial Empire. It's really good. So what I wanted to do for you guys today was give you the what, the why, and the when. And we're gonna split it into 5 parts. And the idea here is what I want you to be able to do is take away is the fact that you'll understand what time series data is, when and why you would want to use it, and when it's actually appropriate to use it. So although at InfluxData, we like to say, stick all of your data into InfluxDB and use us forever and no other database, we're not that narrow-sighted. InfluxDB stands as its own category, and its usefulness is within a specific domain area as a developer. So we're really going to hopefully give you an idea of the best places to use it. And then hopefully I'll end with a demo, and the demo gods will be with us, and the demo won't break, but we'll see. So please hold your fingers for me here. And then we'll have a look at going forward. So where can you guys get started? And that's where I want to talk a little bit about InfluxDB University, and where you guys can get started and where you guys can look to start earning badges and become Influx experts. So without further ado, so let's first talk about the what. Let's really level set here. So I know most of you guys are smart people and that you'll probably know what time series data is already, but I want to really sort of level set the room and give my opinion and our opinion as InfluxDB on what time series data is. So what is time series data? Well, let's first look at the wiki response for it. It's a sequence of data points typically consisting of successive measurements made from the same source of time interval. That's a lot. So really what we're saying is time series data is data with a timestamp, a Unix timestamp in our case, and it's in either a linear or interval motion that we're trying to measure it over, say, the course of a span of a day, a year, in nanoseconds. That is a timestamp data. And you can really divide timestamp data into 2 main areas, the physical world and the virtual world. The physical world one is easy, so consider a temperature sensor. There's actually probably one or a few in this room, and it's measuring the course of the temperature throughout the day. And so you want to know how hot or how cold the room is going to be. That's time series data, and more specifically, that's IoT data, where most time series data lies, but we also see it in other verticals as well. So let's consider the virtual world. So yeah, we could talk about DevOps and other monitoring solutions as time series data, but I think the easiest one to grasp is financial data. So let's consider the stock market. Each day we're trying to monitor the digital assets of a company. So we want to know if they're trending up in the stock market or if they're trending down, whether you want to be buying stocks or whether you want to be selling those stocks because they are plummeting to the ground, just like everyone at the moment, unfortunately. So a bit of a turbulent time we're in. So what are the characteristics of time series data? Well, safe to say they're time-stamped. We can generate regular or irregular timestamps, and a little bit more on that in a moment. They normally come in huge volumes, and they're normally real-time and sensitive. So I was just in Las Vegas, so a little bit red-eyed, and we was chatting with a few of our customers there. And a few of our customers are actually dealing with data in real time in the nanoseconds. So that's really what we're dealing with when it comes to time series data. And these are working for the Ministry of Defense within America. So They didn't want to be messed about when it comes to real time with their data. But that's usually the types of perspectives and characteristics when we see time series data. So I touched on before regular versus irregular. So there is a difference, and this is how we're going to split them up. So what we call metrics, or regular timestamp data, is something that we can manage. We know it's coming. So you can imagine this back to our sensor example. We know we're going to get a sensor reading every minute of every day. So we can expect that data to be ingested. The second is event data. This is when we actually cannot expect when we're going to receive that data. So this is a little bit more interesting, and this is where a lot of people want to go with time series data. A great example here is, imagine if I am a manufacturer and I have a bunch of machines on the shop floor, and I want to know when my machines are failing, and I want to store that data point each time my machines fail. I actually have no idea when those machines are going to fail, so that's considered event-based data. The cool thing here is, especially with InfluxDB and other time series databases, we can actually derive regular metrics from event-based metrics. And the way we do that is through aggregation. And we'll get onto that a little bit later. But aggregation is essentially the idea of, say, either providing a mean or a count of some form on the data. So say if I say, okay, well, I want to know how many times my machines have failed in a day. That's an aggregation. I'm doing a count on the number of events. And so my data now normalizes into metrics. So just to give you a little perspective there, and when you're dealing with your time series data, it may feel uncertain with event data, but it can become regular metrics if that's what you're looking for. So now we've sort of level set on what time series data is. Let's talk about what a time series DB is. So as you all know, you've heard of the three greats when it comes to database architectures: relational, document, and search. And they've got some pretty big names and some pretty big people in there that are doing an amazing job within these areas. But what a lot of developers found is although we have, say, MongoDB that's just now released their own time series database, a lot of these other database solutions just wasn't quite cutting it. Either the performance wasn't there, or either the actual services and solutions that are giving on top of the databases weren't there either. So what I mean by that is you could store your data within a Postgres or a MongoDB or Elastic, all this time series data, but do you have a meaningful and insightful way of returning that data to you so you can ingest it within your own applications? And a lot of the time, it actually becomes difficult, especially when you look at Postgres. See, I've tried stuffing time series data into that if it wasn't for timescale, and I was flatlining that on my device every time. It takes a fine amount of pruning and a lot more bare-bone hardware or a lot more VM resources to deal with time series data in high volumes. And what you see is, this is actually a valid graph, is the actual time series databases are on the upward trend. So this is the progression of time series data here. And we can see there's a lot more people adopting time series databases over any other database on the market at the moment. And that's probably because it's become exciting to deal with time series data. So that's probably why we're seeing the surge. But it's a great industry to be part of, and most people have time series data to play with. So let me level with you. I worship InfluxDB. It's probably why I work for them, okay? I was a customer for InfluxDB before I started, and now I work for them. So InfluxDB to me is the best thing since sliced bread. I absolutely love it. So I would be narrow-sighted if I didn't say there wasn't other time series databases out there. Amazing time series databases, actually. So Amazon TimeStream, QuestDB, TimescaleDB. These are all great databases. But for me, I'm going to level set and give you the golden rules on what make a great time series database from how we see it at Influx. And we're still rated as the #1 time series database. So hopefully the engineers at InfluxDB who helped me with this presentation know what they're talking about. So when we talk about time series applications, we normally split it into 3 phases. you're going to be ingesting, you're going to be analyzing your time series data, and then you're going to be acting. So let's first talk about ingesting and the data model. I think it's really nice. I'm quite a visual learner, so I think it's quite easy to have a look at it in a visual way first. So when we talk about the characteristics of time series data, let's have a look at the humble line graph. So in InfluxDB land, we have a measurement, a tag, a field, and a timestamp. So essentially, when we look at a measurement is your overall container, your describer of what's going on. So in this case, we're looking at stock price. So that's considered our measurement. The next thing to look at is tags. So tags to us are the way that you can drill into your data. That's how you filter your data and separate your data from one another. So in this case, you can see we're looking at 3 different metric types here, or 3 different industry monitors. So you can see these are split into 3 different threads. That's how we're separating these out in tags. This is extremely important, and these are key identifiers, which we'll get onto at the moment. And tags are indexed. Just remember, tags are indexed, along with time. So of course, since we're dealing with a time series database, time is the most important scale here. And of course, time is indexed. So this always runs linearly across, and all of your data stored within a time series database will have a timestamp. That's just the way the cookie crumbles with time series data. And lastly, and most importantly, are your fields. So your fields are your actual values. And within InfluxDB land and in most time series databases, they can be anywhere from strings to ints to floats. We even have binary formats now. So if you want to start looking at storing potentially video data, that's getting a little bit on the rise, but not quite yet. But you can start doing these things within time series databases. So how does that look like? How does that look in text form? Well, what we do at Influx Data is we actually process it as line protocol. And so do you remember those fields, that measurement tag set, field set, and timestamp? This is how it looks like to us. And this is how InfluxDB ingests the data. Now, we have a number of tools that let you convert from common structures like JSON, data frames, the works. So I'm not going to get into that today, but just so you know, you don't have to writing this. I just want to show you the underlining delivery method of that InfluxDB understands. And the reason we do this is because within time series databases, the schema is flexible. So we do not fix the schema of your data. We understand with time series data that it can change over time. You may say add 5 sensors one day and collect, and then you may pull 5 sensors out the next day. And we should be able to account for that. You should be able to retrieve your data no matter how many fields without needing to keep columns as null. So just so you understand that, that's why we use line protocol, to keep it flexible. It is also extremely lightweight. So this is basically just linear string line when you consider it. This is, and yes, you can have as many tags as you want, or as many fields as you want, but the footprint of this data or this payload is very low. So now that we've talked about what the schema looks like and how we're ingesting data, let's actually talk about what what a time series database needs to be. And this is what InfluxDB has become. It has to deal with high ingest, high throughput data. And we do this from building a database actually from the ground up. So we, at Influx Data, we realized that, as we said, the common database wasn't going to cut it. So we actually used industry standard techniques to build our database from the ground up. And this come into 3 different categories. So you might actually be familiar with WAL. So that is the write ahead log. So this retains InfluxDB's durability. And so when the storage engine restarts or where there's a crash occurs, we're not losing that valuable time series data when a problem occurs. The major difference that we have here is we also have this stored in cache as well. So we have a copy of this data. And this retains the high throughput, high capacity of InfluxDB. These 2 components are separate, and the actual storage engine maintains the ability to keep these in sync. But just for your reference here, this is how we keep our durability of your data in case of a fallover. The next is the TSM, which is a time series merge tree. And so if you're familiar with other structures, this is the same as a log-structured merge tree, but just with our own flair on it. And the idea here is to improve the efficiency of how we store time series data on disk. So in terms of retention, I believe we are 4 times the capacity of Cassandra. We are about 4 to 6 times your standard PostgreSQL, and that is due to building the TSM, or the time series merge tree engine, and the file system from the ground up. So we are hyper efficient at storing data on disk. But not only this, we are also hyper efficient at retrieving data from disk. And so the idea here is, and I'm going to read this part to you, this is from the engineers, is the concept here in terms of what we're trying to achieve with the TSM is a little deep, but the goal is always organize values from a series together into long runs to best optimize compression and scanning of queries. And this really falls into the TSI. So the TSI was relatively new to InfluxDB, and this is called the time series index. So what we're finding is, remember when I said tags are indexed? We were finding that as you added more tags, your cardinality could explode. And now cardinality is bad. As we all know, maybe as database experts, the more cardinality we have, the slower your overall machine. It becomes a bit of a disaster, and you're just basically throwing resources at it. The way we deal with that with the TSI is all of our time series data, all of our data series points are indexed. And so the index points are the timestamp and the tags. The idea of the time series index is you want to be able to answer 2 questions. What measurements and tags and fields exist? Given a measurement and tag, what is the series keys? And in this case, it's normally the tags and the measurements. So now that we've started storing our data within InfluxDB in a highly performant way, what we want to be able to do is analyze our data. And what I want to do is introduce you to Flux. It is my belief that any time series database should have a language like Flux. So it's not just a query language. Let me level with you this now. It's actually a functional programming language that lets you build out data pipelines. And the best way to describe it, you can imagine it like a water treatment facility, because we're piping data through it. So you can imagine my time series data is a lake at the beginning. What we're going to do from there is we're actually going to take a range of that data. So we're actually going to take a subset of that data and start to process it. And that's what we consider, I don't know if you can see it very well, is our range here. Next, within a water treatment facility, you'd probably want to filter the water out of your impurities. So that's what we're actually doing with our filtering commands here. So these are all considered query commands that you're probably used to. So within filter commands, we can actually filter out the data that we don't want to see. And that's where tags become very important. So we can start filtering out information, say, within this case, we only want to know sources which are bicycles. So this is a smart city use case where we might be monitoring bicycles, cars, people, but actually we only care about the bicycles in this use case. And we can also do this on fields as well with if, and or logic as well, greater than logic. So we can filter down to a field level. Now, for reference, and the golden rules here is since tags and measurements are indexed, they are faster to filter against. That is just the way the cookie crumbles. With fields, they're not so fast. So the more you can do with tags, the better. And so once we've delivered that, once we've filtered out our data, we might want to change the way our data looks, or we might want to perform some aggregations on our data, so it's more approachable, it's more ingestible to our end application. And that's similar to what we're doing here in a water treatment facility. We are funneling it into a new system ready to be delivered to the masses. And so if we look at our examples here again, we're actually performing an aggregation window. And so that's a really important feature of time series data. In most cases, unless you're a data scientist, having all of the raw data all at once is probably not what you want. Having a calculated mean or a mode of that data is probably more interesting because you're still retaining the overall descriptiveness of the data, but you don't need to see it in such high fidelity use cases. So here's some of the features that you can do with Flux. So you can actually query SQL and CSV as well as time series data. So it is actually multimodal, it can go across the board. You'll be used to some of these here within the query section, so filtering, aggregation, you can perform joins on tables with your data, and you can also pivot your data. Here's where things get interesting and where a lot of query languages can fall short. So you can actually start looking to analyze your data. This is where you start performing common mathematic calculations on your data. You can start mapping to other columns based on your time series calculations. You can start looking at anomaly detection with Flux as well. You can have a look at outliers. You can start looking at correlations with your data as well. You can now downsample your data, which was referred to back with aggregations. And if you have custom business logic, since it's a functional programming language, you can actually apply your own custom functions to Flux. That's how highly flexible it is. And lastly, you want to be acting on your data. And this really refers to sort of conditional logic, so the ifs, ands, and ors of a functional programming language. You can actually perform checks, alerts, and notifications, on which we'll get to in a bit. And you can actually output the data through Flux as well. So there's a number of ways you can get your data out of InfluxDB, but if you want to do it all on server side, you can actually do it through the data output through, say, HTTP, MQTT, Slack, Teams, the works. There is a number of plugins to get your data out of InfluxDB purely just through Flux. So, and lastly, but not least, is you want to be able to take action. And so with the release of InfluxDB 2.0, we combined a lot of features of what we call the tick stack. And the tick stack combined a lot of services such as visualization, a task engine, and a real-time analysis engine all into one product. So what you can see here is I'm a strong believer in the ability that once you store your data within a database, it should be easy to visualize and process and ingest your data. So we actually have a user interface in InfluxDB that allows you to dashboard completely out the front of your data. And that is fully UI based, so you don't have to learn any code or have to create any widgets yourself to start viewing your data within a dashboard. And I'll demo that a little later on. And also what we have is a task engine. So it's all great running queries yourself or maybe your own application, but maybe there's certain queries you want to run on a linear basis. So maybe as part of a cron job or as part of a sort of hourly interval. We actually have that embedded within our time series database. So a great example of this is downsampling. And lastly, we also have a notification service. So you can see that here, MQTT, Teams, PagerDuty, REST, Slack, the works in terms of sending data out in terms of notifications from your tasks. Just making sure I'm doing a time check and not wailing on. Right, so now we've sort of discussed the what a time series database is. Let's have a look at the why. And I thought the best way to do this was so this is what I was presented with on my first day. This is all of the use cases for time series data, all of the different verticals where we can be used. And I'm like, as a developer, I actually want to start working on this myself and see where time series data is useful. So instead of trying to go through all these and all of our customer use cases, which I think is kind of boring, I want to show you my home projects that you can actually do at home, because I'll give you the source code at the end, that helped me learn where time series data is useful. So first was IoT plant monitoring. I thought this was a really cool use case, and we called this Plant Buddy. This allowed you to take an Arduino device, hook up a bunch of sensors to monitor your common household plants. And to do this, we monitored the moisture levels, the temperature, the humidity, all with about a device that was around about 30 pounds. We then processed that time series data directly into InfluxDB, where we could visualize and perform notifications on that data. So you can see the setup here. I left you just a little bit of a circuit board of how we ended up designing it and the types of sensors we used. And the overall idea here is if the moisture of the plant dropped to under a certain level, then I wanted to know about it. So if it was under 40%, I know I should go feed my plants. Not saying that I actually did feed my plants. Most of my plants died, but I tried. At least Influx was working and told me that they were thirsty. So I do feel a little bit guilty, and I will become a better plant dad at some point in my life, just not now. And so here you can see some of the visualizations that we were running directly in InfluxDB. So as an IoT practitioner, I will always say that the visualizations are great from InfluxDB, but if you want some truly in-depth analysis on your time series data and some really nice visualizations, then I always recommend Grafana. Grafana is a fantastic visualization tool. We've been partners for them for years, and they just know what they're doing in terms of visualization. So if you're especially doing this in a professional setting where you're probably looking at a factory floor or other settings, maybe DevOps, looking at server monitoring, definitely have a look at Grafana as well. But if you want to do some of the basic visualizations and look at your data and this is enough for you, then InfluxDB UI can do a lot of it for you as well. And then, of course, the notification. So this was me telling me that my plant buddy was getting, as you can see, increasingly low, and I wasn't doing a very good job. I must have topped it up by a few percent. It wasn't great. So just on that note, so we actually have two different, let me quickly skip there, we'll come on to this in a second. We actually have two types of checking that you can do. We actually have threshold checking, and we actually have dead man's checking. So threshold checking is exactly as it is on the tin. If it goes up over a certain level for a certain period of time, if it goes down below the level for a certain period of time, that's threshold checking. And you can get quite deep. You can get basic to quite detailed with that within Flux code. So you could either do it the moment it hits a threshold, or you could say, actually, well, I want to know if it stays constant for a certain amount of time, then alert me. That's the power of time series data. The other is dead man checking, and this becomes really important with servers and IoT devices. This lets you know if you're still getting data from that device. So what we can do is we can set a time gap to say, suppose someone's tripped over the Ethernet cable and pulled it out. If I'm no longer receiving data after 10 minutes or so, then I want to be notified that no data is coming into a time series database. So that's another powerful concept that you can use within alerting. Second use case, which I'm actually going to hopefully demo for you guys today, is the Vision AI person detection. So the idea here that someone asked for us to do was, suppose we had a shopping mall and we wanted to count the number of people or evaluate the number of people within the room. And so the idea here is to set up a Vision AI pipeline and then ingest that data directly into InfluxDB. So to do this, which you can actually see them here, which we'll get onto in a moment, I used a webcam, an edge device, which in this case is a Jetson Nano. I highly recommend it. It's like a Raspberry Pi on steroids. It's just got like a NVIDIA GPU embedded. I used NVIDIA DeepStream, so there's some great content from there. And then I brought it all together using Python. So I ended up using MQTT. And another tool that Influx is custodians of, which is called Telegraph. So Telegraph is basically an open source metrics collector that is used all around the world for ingesting data from just about any type of source. We have a plugin, we have over 300 plugins now, so we can pretty much connect to just about anything. So the idea here was not only, so what I did is I actually demoed this for our head of development. And he said, this is great, you've just shown me another dashboard of visualizing inference metrics, but can you do something more interesting with the data? And so I came up with a bit more of an elaborate plan. And this is where we started looking at how time series databases could be federated from the edge to the cloud. And this is now a core feature within InfluxDB and something that we are progressing with in a heavy way into the future. So my device here has limited resources. It's processing the Vision AI model, but it's also running InfluxDB and storing that data, every frame per second. So running any heavy calculation on that data on that device is, we're probably running this at max capacity. That's just the way it is. So my idea is that we'll process the raw data on the device itself, but any other core analytics we want to run, we'll run it on InfluxDB Cloud. And so InfluxDB Cloud is our SaaS solution. So you can run that for free in InfluxDB Cloud, and we also have paid tiers and so forth. But the idea here is we would take the aggregated data from the edge, put it into the cloud, where I was going to perform some more interesting analytics on it. So here was a sketch of what I was trying to do. So my goal was to find out whether the camera placement affects the overall model confidence. And my hypothesis is that if your detection is in the outer box of the frame, that it would be a lower confidence to the center point. So in order to do this, I first aggregated my data over a 24-hour period, and I only took the hour's worth of that data, the mean every hour. Because to calculate this, I don't really need to see all of that data all of the time. I can only do it, doing over the aggregation of a day was just more interesting to me, and it was less data to send to the cloud. Next, what I did was I run a flux task that kicks off every 24 hours. So this flux task connects directly to InfluxDB Cloud and offloads the aggregated data from the edge automatically into InfluxDB Cloud. Next, I actually did some calculations within InfluxDB. So I actually worked with one of our other developer relations, Anais, who's a much better data scientist than I am. So she helped me with the calculations here. But what you can see is essentially what we were doing was calculating the center point of the frame, and then we were working out where the center point of the bounding boxes were and checking the confidence levels and looking for correlation. So we actually used an out-of-the-box algorithm within Flux, which is Pearson R. And as you can see, my hypothesis was a disaster. It was not correct. It didn't matter where you was on screen, you could get the same level of confidence. So there could have been some correlation, but based on the data that we had collected, there wasn't any correlation at the time. But this just shows you that we can keep running this test over and over, and as we change in and out the models, this actually might change. And this is where the power of time series databases come from a DevOps and AI solution. It allows you to continuously monitor your solutions and make sure that you're running to the best of your abilities. So let's talk about the when, and I like this bit. So this is where I get to ask you guys questions after what we've just discussed today. So online store, the goal is to store and process customer orders and retain customer accounts. Should we use a time series database for this? Hands up if we should use a time series database for this. Good. We've got a listening audience. Fantastic. Absolutely not. We should use a relational database for this. This is not what time series data is for. We might use time series database for looking at analytics on the store, maybe like the number of clicks over a period of time or where user trends are going, but definitely not for processing customer order transactions. That is most definitely either a relational database. You could potentially look at others, but just in common standard. So, hands up again. Should we use a time series database for collecting performance and health stats of our infrastructure? Hey, fantastic. Yes, 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 yes. It is. It is a time series database. So, next one, video, blogs, and platform. So we're going to do this to maintain, manage, and track upload videos and blog content from our users. Time series database or not? So in this case, DocumentDB. So I would say you could potentially track the when a video was uploaded or why, but in most cases, if you're maintaining or managing content, it's probably not a time series database. And last one, a trading platform. So our goal here is to store and visualize the current state of financial market data, alert on trends, and process user trades. Awesome. So would anyone else like to say otherwise? Would anyone like to be confident enough for a pair of socks to say different?
This is the process user trades. I don't know.
So I mean,
that's the use case for it.
So you're fair. So you're right. And this is what we're going to go on to. Let me offer you this. We'll do the Oprah of you get a pair of socks. Or disasters. So in this use case, I added a trick question here. So these two here are fantastic use cases for time series data. But the catcher outer here is processing user trades. And so in this case, it would be a hybrid approach, potentially using a relational database or a document. And this is where I wanted to really drive home that a time series database won't solve all your problems, but they can actually be used in a hybrid approach. And this is where Flux really comes into its own. So Flux has a SQL driver all plugged in, which means you can actually aggregate and combine your relational data with your time series data all within one platform. So it's just to show you a bit of a hybrid approach here, that you won't be using, a time series database won't be your one check all. You would definitely probably be using it within a hybrid infrastructure, unless you're doing something as standard as DevOps monitoring. And so here we go. So hopefully the demo will work. We will see how we get on. So let's see what we've got. OK. So we was detecting a number of people in the room. I must admit the model isn't so confident all the time. It's trying its best. The idea here was to detect the number of people in the room. So I think the confidence level I set it to was about, like 50%. So it's an interesting model, and I was quite interested to see what it would be like with a number of groups of people in the room. I don't think the webcam resolution is great either. But the idea here is to show you how we are storing and maintaining that in Influx. So I quickly log in here. So this is InfluxDB, and this is running on the device. So this is running on the Jetson Nano. And you can see the visualization and dashboard that we're running here over the course of the time. And you can see a number of visualizations that we're running. So you can see the actual confidence of the model. You can actually see sort of the frame number we was on, where the average bounding box height and the bounding box width is. You can see the detection confidence for the number of tags. And you can see what we were detecting. So someone in the room looked like a bicycle. I'm very sorry. But this is all important data. So clearly the model is faulting somewhere because we shouldn't be detecting a bicycle in the room. And this really shows you the visibility a time series database can give you over these things. Instead of looking at linear text files of logs where you might not pick up for a second that there might have been a bicycle, it really shows. And of course, we can start looking at timelines of what we've detected. And as you can see, this was me testing it. So this one linear line here was me testing it before you guys entered the room. And now you can see we've started adding tags. So tags are where we saw the definition of splitting our data. So my tag here was the person. Sorry, so the object detected. So the object detected could increase linearly. So say if there was 50 different detections on screen, I would have 50 different tags, which was splitting up my data. So it means I can track each person or each object in frame individually and start looking at analytics specifically on that data. And hopefully if the internet gods are with us, let me quickly check here. So I actually have a task running which is edge to cloud. And so this is running, what did I set it to? This is scheduled to run every 30 minutes. And so it looks like we're running successfully. Let me quickly run the task and make sure. So you can see here is the Flux code. So this is what we're doing to basically process the data and send that to InfluxDB Cloud. So just to give you a quick overview, so we're running this at 30 minutes. You can actually set an offset for your data, for your task to run as well. So that means that you don't have tasks running in parallel with each other, so spiking in terms of resources. What we're doing is we're collecting the data from the edge inference bucket. So if you're used to relational databases, a bucket to us is the actual database itself. We're going to collect the data from the last successful task run. So that's a really cool feature within the Flux language. It allows you to be a little bit more dynamic with your Flux query. So instead of putting in a static value there, say minus 24 hours, I can actually say when this was last run, I want the data between that and now where I'm running the next task. I'm then going to filter for the measurement, so I want all of the inference results. I actually want to keep all of the fields and all the tags. I'm going to aggregate that data, so for every 10 minutes, I want the last value that was received. And then I'm going to pivot that data. So when we pivot our data within time series databases, it looks a little bit more SQL-like. It's more columnar in approach. I'm then going to set a new location. So this is a new tag. So I'm just going to say this is London. So this is really cool when we're dealing with federate design. Supposedly I had these all over the places in different shopping malls. You can start adding metadata when you start aggregating the data to the cloud. And then I'm going to drop two values. I'm going to drop the start and the stop because they're not important to me anymore. I already have the timestamp that I want. And then this is the function. So this is no longer experimental. This is the to function. And the to function allows us to send our data directly to InfluxDB cloud. Now, let me see if I can quickly show you InfluxDB cloud and see if we're aggregating the data there. Jump in. Internet's not too bad at this event. I'm quite impressed. And let's jump in, and then let's have a look. So I think it's our inference results here. Fantastic. And this is where I've been starting to offload that edge result data, and I've actually started putting it into the cloud. So you can see where we're starting to calculate our Pearson's R value here, and start to look at correlations between the confidence of our data here. So you actually have a little bit of flexibility with Flux. As you can see here, although it's time series data, over the course of a time, we can actually change the x-axis as well. So we can start looking at correlations between, in this case, is the frame and the confidence level. So hopefully that just gives you an idea of the types of things that you can do. So this is considered AI and DevOps monitoring. So this is really to help people that develop models in order to maintain them and make sure that they are improving their model continuously as model value degrades over time. So let's quickly jump back into the slideshow and then jump to last. So next steps. So this was brought to you by InfluxDB University. So this is a new initiative that we just released at Influx Data. And so this allows you to get started learning InfluxDB. It also allows you to earn merits through InfluxDB. So you can become certified as an InfluxDB user. In the end, we hope to have a full certification within this. So you can actually say on LinkedIn and other places that you are InfluxDB architects and users. So it's a great place to learn and get started. There's Flux courses, Telegraph courses, InfluxDB essential courses. If you need any of the links for anything afters, you can come talk to me, and I'll give you those links. Next, I want you guys to have the code. So I've uploaded for both these demos the code on GitHub, so you can use it and try it at home. I'd love to see what you guys come up with. So Plant Buddy was the plant monitoring solution. So if you want to try it yourself, you can. And then if you have a Jetson Nano, then you can actually run this demo here with the Jetson series Vision pipeline. So I've just left all the code up there. I would love any pull requests, any shaming on my code. That would be fantastic. I promise I'm not a great coder, so it just works. Okay, that's how it works. And so lastly, come join our community. So that's where I sit. That's our fantastic community, InfluxDB. We're almost 3,000 strong now and growing. And most of the time, if I don't answer the questions, then it's our lovely developers and architects on there that do, or even the rest of our community. We have a fantastic budding community, InfluxDB community. So please come join us. It's a fantastic community to be part of. And so lastly, any questions? Socks for any questions? Yeah.
Is there a use case for this where you have like event sourcing or something like that? So is that like a sort of pipeline that you would envisage if you have like a, say, I don't know, an e-commerce site with lots of transactions going on, potentially lots of events being raised and then being processed, some sort of materialised view at the end of that? Would you think Influx would be suitable for that kind of use case?
So definitely. So I mean, so you can even process it down to a log level as well. But what we say is you always make sure you pass your data into numerical values or the way you structure your data, rather than just shoving that log. So you can store log data, and you could store direct event data. Say if you were, I don't know, looking at Kafka integration, because that's probably where you're doing a lot of processing for that type of data in terms of transactions. You could store that rawly within InfluxDB. But if you want to look at the analysis over the course of a period of time, I'd definitely say passing your data would be beneficial to you in the long run. You can use Flux to, so what we've had in the past is people would shove all of their raw data into a bucket, and then they would use Flux to parse that data themselves. So they would take out key stats from that data. I don't know, best description here is they've fired in all of the logs for their servers. And all of the logs might have critical or warning levels within the logs. They're using regex through Flux to pass those values out, aggregate that data into a count, and then this becomes the ability to send that data to a new database where they keep all the analytics on that data. So it's most definitely possible. It's just obviously it becomes a resource burden how much you're pushing large amounts of raw data at it. Yeah. Here we go. We're going to try this again. So. You got that one. Yes, go on.
Very simple question. Would you see the use of things like POS data to be fed into the time series database to be used in labour forecasting in demand? Is that a valid use case?
So what database did you say, sorry?
Just POS data, so one size of data to say X number of items have been sold in a 15 minutes period, so real-time data fed in that way, to be fed into something to do analysis for labour forecasting in demand. So you can build demand trees to say, well, we predict based upon this, you're going to need this many staff to be able to store based upon this trend moving forward in time.
Definitely. So that's a great use case in terms of looking at trend data over time. I think there are other service providers and companies out there that are providing one-stop solutions, which is like Datadog is probably a bad example in this case, but there are other use cases that provide those stock market, the analytics on your trends on your data. But if you want to have more control over your data in the way you do it, or maybe you have some custom business logic that you want to employ, then using something like InfluxDB to deploy that, yeah, I think that would be a great use case. I mean, I don't know if I can get you a sock from there.
Just throw harder.
Yeah, throw harder. As you can see, I was never good at sports at school, so especially throwing. There we go. Fantastic. You, sir, and you, sir.
I was going to ask, you talked about alerts and notifications, and you sort of threshold values. But what about, can you detect sort of the, sudden rises, sudden falls? Can you configure, events based on, if line rises over this threshold? Can you sort of potentially rate of change? How well developed is that?
So yes, so we've actually been, that's a really good point, because before it was quite limited in what we could do. So what we're finding now is people want to look at states of trajectory of their data in that way. And so what we started to employ is basic forecasting as well, to start looking at this data. The name is escaping me now of let me see if I can find it. Of the types, the forecasting algorithms that we deploy. But what we're also doing is we're actually partnering with a number of time series AI experts. And what they're doing is they're actually going to be integrating their plugins directly into Flux, which allows you to do some more interesting calculations within their engines on that data. If you have you can actually, if you know directly, you can employ that logic yourself through the programming language, so you can directly have a look to say, over the course, if I've struck from this level in terms of conditional logic, this spike, then you can say, okay, yes, this is a significant spike in my data, I want to know about it. And that's why Flux is quite customizable. It's in terms of how you deal with that data. If we talk afterwards, I can give you. I'll give you my of my sort of higher up, which is Anais. She's an amazing data scientist and a flux master. So she would be able to give you advice on how to be able to do that directly in InfluxDB as well. I must admit, I sit more on the ingest side of things rather than the analytics side. I definitely know it's possible, but I definitely think it's better to get you to the right person to have the conversation with, rather than me spraffing at you. There we go. Hey, good one. Go on, my sir.
How about enterprise features like high availability, backup, restore, running in a cluster? About that?
Yes, of course. So we do actually have InfluxDB Enterprise. So the only thing that's closed source with InfluxDB is high availability. And so you can run that as a cluster or on-prem or in the cloud yourself, and that's maintained by yourself. If you want a SaaS solution, then there's InfluxDB Cloud, and then we maintain the cluster and the high availability on your behalf. So I would recommend most of the new features come into InfluxDB Cloud, and then they come into the next release of InfluxDB OSS and InfluxDB Enterprise. So I definitely recommend going to cloud if you can. But as an IoT developer, I completely understand that most systems need to be air-gapped. So I highly recommend having a look at Enterprise if that's your requirement. I didn't tell you this, but there is a layman's approach of doing high availability. We have a new feature now, which, you saw me running aggregation with a task and sending that to the cloud. We actually have a new feature called data replication, which you can actually use between a node-to-node basis. It's not true replication, but if you want to start backing up your data to, say, a secondary InfluxDB, just in case this one fails, then that's also possible. But yeah, in terms of having true scalability and true durability, then InfluxDB Enterprise is where you want to be. There you go, my sir. Wow. Yes, go on.
We've got lots of IoT devices going on streaming. Is there anything to actually manage authenticating and making sure the thing you're talking to is the IoT device?
So we do have a token system. So because we actually can now talk directly from Arduino devices to InfluxDB. And let me quickly see if I can show you it here. I don't know. Okay, on time. Let me quickly jump into buckets, API tokens. And so what you can do is you can generate a custom API token, and you can get down to quite a granular level when it comes to tokens. So let me quickly jump into buckets. So you can actually get down to the point of what database you're writing to in terms of being able to read and write from that database and the level of control that that device has. So if I just quickly say I only wanted access to my downsampled bucket for writing, I can generate that, and that generates me a token that I can use. I'm obviously doing this through the UI, but you can do that dynamically through any of the client libraries or through the API. So you can have your device talk in that way.
Would you generally put it straight into Influx rather than putting Telegraph in front of it or something as your way of shoving data in?
So I am a huge advocate for Telegraph. I personally would say I love Telegraph because it allows you to maintain and manage a queue for your data, so you don't have to worry about the code for that. So what are you using in terms of have you got a number of IoT devices that you're using, or?
I'm just thinking about I guess doing IoT properly.
Yeah.
Using certificates and hardware crypto to make sure you are talking to the right device and whether it's the thing sending you the data, whether there's anything in the stack that helps you with that bit of the problem.
Yeah, no, that's fair. And I would suggest using Telegraph as a bridge there. So Telegraph handles a number of certificates. So when we're dealing with, say, OPC UA or MQTT conversion, you can deal with certificates and SSL authentication directly there. And then any sort of offloading to InfluxDB, you can do directly through authentication methods there. And then there's obviously standard practices on where you're running Telegraph, maybe keeping like tokens if you're using those within locked files, environment strings, whatever you're doing. But I highly recommend using Telegraph as your collection point. It also gives you a bit more control, and it also allows you it gives you a fail-safe. So suppose like you lose connection, instead of having to maintain that fail-safe within your own client application, you can maintain that fail-safe with Telegraph, because we'll store the data within a buffer for a certain period of time, and then offload that data to InfluxDB when it's ready. So it's a nice survival technique for your data.
Good, thank you.
No worries. Here we go. I'm scared I'm going to hit the gent. Hey, oh, close. So I have 5 more socks left. It could be any question. It can be a dumb question if it wants to be. Hey, yes.
Kind of how much data do you need to be ingesting to kind of make this worthwhile? Right? Like if you haven't got something that's recorded 24 hours a day, every second kind of thing, like we have some potential use cases like open banking data and things like that, where you might get a bulk of data for an individual customer in one go, and you won't see anything from them again for ages. Like, does analyzing transactions and things with a time series database make sense in use cases like that, or is that just you may as well pack it over the top of a non-time series database?
No, absolutely. So our customers stretch all the way from dealing within the nanosecond of data all the way to looking at, say, a quarter or yearly period of that data. It really sort of doesn't matter with your time series data. So it may seem a little bit of it may seem a bit, what's the word I'm looking for? Colliding in the approach that we actually have a retention policy on our buckets. So what we do say is with certain time series data, it becomes less important the more historical it is. So we have an automated method of clearing out old time series data. But you also have the ability to basically create an undefined measure of time. So people are looking at their data over a 5 to 10 year period and looking at correlations between, say, when these customers are doing their transactions then to when they're doing customer transactions a year from now. So, you shouldn't feel restricted in terms of when to use this. So the data is obviously only as good as the data you're putting in. So if you say putting a chunk of data for this year, and then you're not expected to see anything till next year, then you're probably going to reap the results of that data when you look at correlations on the next year's worth of data.
Yeah, I'm thinking like if we get a few months worth of data in like a dump, and then we want to analyze over that 3 months.
Oh, most definitely.
And then we probably won't get another 3 months of data for a while. For
Yeah.
that individual.
You can set unique time ranges as well, so you can just make it within that 3-month period. And just so you know, within bulk upload, it doesn't matter the order of your data and how it's, as long as it has the timestamp, because that's the index, we will insert that data wherever it needs to be within the database. So it means you can upload historical data all the way back to 1970 if you really wanted to, and you can put in future data if you're looking at future transactions as well. So it's really flexible.
Does that impact like the processing time thing if you do a bulk insert rather than like incrementally adding things on for analysis?
So in terms of InfluxDB's performance under a standard system, we're expecting, we can do process like 1 million metrics a second in some cases. So I've got no problem in terms of it really. Maybe if you're talking about tens of millions, then okay, let's have a conversation and we can look up how you would want to divide your data as a bulk upload. But unless your data is incredibly rich in tags, then I don't see a problem doing that at all. Yeah. Socks. Fantastic. Here we go. Oh no! That was a truly special one. I hope you got that on camera. They'll drop down at some point in another conference. It'll be raining socks. Sorry, after you.
Yeah, I was going to say, in a situation or environment where you have multiple nodes or multiple clients generating data points at high speed, do you have a mechanism for ensuring entropy of events, or do you rely on the clients keeping accurate time with each other?
So in terms of, are you just syncing timestamps of when they're coming in? Yeah. So it's really, so that's up to you. So you can either have, within your payload, you can send the server timestamp, specifically the Unix timestamp, down to the nanosecond if you want to. And InfluxDB will take that as its key store. So if you want to govern it by the device, then you can. If you don't send a timestamp with the data, then the moment it hits InfluxDB, that's when it will deliver or generate the timestamp on that data. So by default, it's the InfluxDB deals with data, I believe, on the millisecond. So it will deliver a millisecond timestamp on that data. But if you're dealing with data to that level, I would highly recommend making sure that you're delivering the timestamp with your client application.
So in the situations that you mentioned where you're dealing with nanosecond measurements, was that all coming from a single source?
Yeah, so multiple sources, sorry. So in terms of dealing with that, so this sort of plays back into the Ministry of Defense. They have multiple devices that they are pumping through from the nanosecond with. What they did was a little bit special in the fact that they decided that the throughput wasn't good enough for using Telegraph or one of the client libraries, so they actually built their own client application for ingesting high throughput data to deliver directly into InfluxDB, and that retained the nano timestamps that they needed, and that, in terms of being stored on InfluxDB, was relative to when those nanosecond timestamps came in. I hope that answered your question. Sorry, yeah. Oh, socks. There you go. Right, try not to lose any more. Here we go. Whoa. Oh, that was a shocking one. Sorry, was there one on this side?
Yeah, I was just thinking about cardinality. It's like, say you have IoT devices everywhere, and one of the things that you want to track is the specific location, or if you want to be super granular coordinates. Like, is that something that Influx can deal with, or is it like completely not in the use case?
It's a fantastic use case, and so that's something that we're actually working on at the moment. So let me, this is a very basic use case with coordinates. Let me see if I can quickly show you. 2 seconds. Let me jump into notebooks. Let me jump into emergency generators. I don't know if we got... So we actually do have a map feature, and we do have the ability to deal with coordinates and geodata, and it's quite, so we can even look at, so there was an example demo piece where we looked at migration of birds over a course of a period of time. Now, if your coordinates are updating constantly, don't store them as tags. That would explode cardinality. You're completely correct. If you store them as fields, although that the processing of the query will be slower, you can deal with that. Now, I do admit that when you're dealing, say, with plus 1 million devices potentially, then you might start running into cardinality issues, especially on certain devices when slowing down. So what we're actually doing at the moment is we're doing a huge rewrite of our backend. So we're actually going to be releasing InfluxDB IOX in the upcoming year, and so that's built on Apache Arrow projects. And that's meant to basically remove cardinality as we see it. So deliver a true columnar experience, but with no cardinality issues whatsoever. So stay in the space for that one. So we're basically we're already testing it with certain customers, and we're basically migrating across to that from cloud first, and then we'll bring that onto our edge solution as well. Let me.
Oh, I've already.
Oh, you did, didn't you? Yeah. Do you want to donate? Have you got to point someone out? Do you want to donate the socks to anyone?
Yeah, but who wants one?
There we go. I'll jump across it. Yeah, we've got a question as well.
Yeah. So if you look at
Sorry, he was a donation. There we go. Sorry, go on.
So if you look to get into geodata, are you doing for geospatial stuff like collision detection? Say you've got some geographies and you want to enrich data with which geography is contained, for example?
So yes, we do have like, if I can answer that, we do have like S2 cells, and we do have other ways of enriching data. You can use directly raw coordinates and then just apply other columns in terms of situational to that data. So I don't know, maybe in terms of looking at regions, you can use the S2 cells within that to say this happened all within the America region, or this happened over here. In terms of other abilities, we actually have a geo package within Flux, so I highly recommend checking out that, and that gives you a bunch of flexibility on what you can do with your geo data. But we're always open to more suggestions on building out that geo package if there's more unique expertise that you have in that area that you want us to look at. Yeah, go on, last pair of socks, the last question.
Is there an ability to sort of pre-analyze your data? If you're having, let's say, error rate, can I work out the rate sort of errors as events? Can I work out the error rate or integrate under it and then store that for future queries to analyze?
So, yeah, so essentially what you're saying is that, say if I have a number of events coming in, so a number of time series events coming into the InfluxDB, you want to know the error in terms of what you want to know the amount of errors that's happened, or?
You'd be able to integrate under it to get your error rate. But I'm imagining most of my queries will want to know the error rates rather than having to go to the raw data and calculate it. Can we persist that rate back to the database?
Almost definitely, and that's where you look at like the aggregation, such as count techniques and stuff like that. So what we can do, instead of just looking at aggregation windows, and look at the course of that data over a period of time. So they're not going to look at the raw data within that regard. You basically store that data, and what you could do is run a task if you wanted to analyze that data, or if it's part of a dashboard or say a notebook that you're giving off to your user, you can run that query on demand to basically say, over the course of this amount of time, there was this many warnings that's happened, or this many errors that's happened over a count period. Yeah. Here we go. Oh no, there we go. I'm going to have to find a better launching technique for socks in the future. Fantastic. I think that's me running over, guys. But thank you so much for your time. If you have any other questions or want to chat, fantastic. My doom is in your fate, or whatever. There's a rating system. So I won't look. You can leave unhappy faces. It's okay. So please, the organizers asked for you to rate your experience so far. But thank you very much for your time.